Hi again, everyone. So this talk is about SQL property graphs in Oracle Database and Oracle Graph Server. So as we've already learned today, SQL PGQ is now officially published. Part 16 of the SQL standard is the property graph queries. So SQL property graphs are defined on top of existing relational, but also possibly JSON data. So that means you don't have to copy or transform any data because it already exists. In order to create a graph, it can be done very quickly. The same transactional consistency that you get for tables also apply to graphs. And you can, thanks to JSON and also XML, which is already part of SQL standard, you can optionally add schema-less data to your graphs. And then Oracle 23c, which is the latest long-term release of Oracle Database, now has an implementation of SQL PGQ. In our documentation, we don't refer to it as SQL PGQ. That's just a term we use for the standard, but we simply say SQL property graphs or property graphs in SQL. And there's various reasons for having property graphs inside a database, like Oracle's. So there's extreme scalability thanks to leveraging all the existing SQL optimizations that have been added over the years. Security, so a graph is a first class object, just like a table. So there's graph level security, but since Oracle Database, for example, also has row level security, we now also have vertex and edge level security. Thanks to all the features in SQL, you can do things like do a graph query and create a view on top of a graph query, or join property graph data with relational data, JSON data, XML data, spatial data. And you can also create PL/SQL or JavaScript stored procedures and invoke those from your graph queries. And another huge benefit of this effort is that all existing SQL and development SQL tools and development environments also work for graphs. So for example, Apex, SQL Developer, SQL Sail, but also drivers for all the different languages like Java, JDBC, Python, C. So through all these existing interfaces, you can now run graph queries. And there's more benefits like flashback technology, data pump. So Oracle Database, of course, started as a relational database, but it's no longer, I mean, it still does relational, but it's what we now call a converged database because it has relational, JSON, XML, and now property graph. Converged database means more than just multi-model. It also means different support for different workloads like analytics, AI, machine learning, all in one database converged together. And then recently Oracle released Oracle Database Free, so it's for developers. You can very easily download and install a Docker image and get started with Oracle Database. And this release includes the new property graph support. Okay, so now let's start with an example where we create a graph on top of a relational schema. So here we see a relational schema that has only 3 tables with a whole bunch of columns. And the first table, so it's basically customer and customer sales, and then we have movies. So customers are buying movies. And then this is the kind of graph you can create on top of that. So we have one table for customers, maps to customer vertices, and then we have a movie vertices, and then the table in the middle corresponds to the edges between customer and movie. And that graph can be created through this statement that you see here on the right. So it's only 7 lines of code. So I'm sure people here have created graphs before, and that I bet it typically takes a lot more than just 7 lines of code. But of course, that's possible because the data already exists in a database in relational form, which is typically the case for our customers. And then this is also making use of existing primary and foreign keys. So for example, for the edges, the foreign keys are reused so that you don't have to specify them when you create a graph. So here we create a similar graph, but this time we assume that there's no primary foreign keys existing, so we specify them inside the statement. So here we say the key of the customer is customer ID, and we also specify properties. So normally all the columns become properties, but if you only want to have 3 columns to become properties, then you can provide this list. You can also see this cost ratio. It's basically a more complex expression. It takes the budget and divide by the list price, which are 2 columns, and then exposes that as a cost ratio property. And then the edge tables, we have source key. So if you don't have foreign keys that can be reused, you can specify the keys here. And you can also rename columns with different properties. And these are just some details. The main takeaway points are that you can create these version and edge tables on top of existing base tables, external tables, or materialized views. And then the data model is such that a vertex or edge table can have 1 or more labels, and each label can have 0 or more properties. So now that we've seen how to create a property graph, this is how you can query a property graph. So select from where group by order by are the existing SQL constructs, and then the new thing is the graph table operator. So SQL from clause can take any number of table expressions in the from clause. So you could have multiple graph table or graph table together with something else. Here we have a single graph table. Inside the graph table, we have a graph name, and then the pattern inside a match clause, where clause, and columns. Columns is like a projection similar to select clause. So here we see an example. Let's find all 2 customers who rented the same romantic comedy movie, one after another, and after February 14th. So we say graph table, the name of the graph, and then we match customer 1 who has an ad to a movie, and customer 2 has an ad to the same movie. And then we have a couple predicates, for example, saying the genre of the movie is romantic comedy. And then we project the last name of both customers, as well as the date rented of the earlier customer. And then since we have select star in our query, these 3 columns become the final result columns, and then you can do an order by. Now a little bit more complex schema. So here we see 5 relational tables. The 3 tables on the left are typical vertex tables: person, company, place. Where the tables on the right are typical edge tables. We have person knows person and person adores place. But as you see in this figure here, we have 2 more types of edges works at located in. These actually come from here, from these person and company tables. So sometimes you can use a relational table both as vertex and as edge table at the same time. And one thing to pay attention to is also this JSON data type. That's now SQL standard supports JSON as native data type. And this was also added to Oracle database. And therefore you can you can do things like what you see here is that we have in the graph, we have a property name, city, zip, birth date, but these actually are values from within a JSON object. So we have the JSON column with its name details, and inside there we have an attribute name. If we look at, for example, credit score, this must be a JSON array. So there must be multiple credit scores per person, and then we take the average and we expose it as a property, vertex property, average credit score. So this syntax is named JSON simplified syntax, so it is also part of SQL. And then we have the edge tables, as previously mentioned. Knows and adores are straightforward, but person table basically contains the works at edge, and the company table contains the located in edge. And then again, we have created this graph. We can run a query on it. So Bob needs to buy a house. Wants a loan to buy a house in Seattle. So the bank wants to check, does some background check. How many friends and friends of Bob work in Seattle and understand in order to understand his likelihood of his social integration? So we can see here in the graph pattern, we have P is a person, knows a friend via 1 or 2, knows hops. And then a friend works at a company, and the company is located in a place named Seattle. And then we get the name of the friend or the friend of the friend, as well as the zip code of the friend. So in prior years of LDBC TUC, I presented about PGX, property graph query language. So how does this relate to SQL at this moment? So in Oracle Database 21C, which is the previous long-term release of Oracle Database, PGL is the primary way to query property graphs, and majority of customers using property graphs at Oracle, they still use PGL. And there's two ways to run PGL. So one is a translation into SQL, where we translate the recursive width as well as PL SQL, for example, for the shortest path queries. And the other one is PGL and Oracle Graph Server, or PGX, which is a specialized in-memory graph engine. And you can very easily load a graph that exists in the Oracle database into the Oracle Graph Server. It's very well integrated. In Oracle Database 23C, which was recently released, we now have the new SQL syntax. And we do expect that over time, SQL will become the primary way for Oracle customers to query property graphs. And therefore, we are trying to align things, PGL and SQL, better so that Oracle customers have a more aligned experience and make things more interoperable. So what we have done, you don't need to understand this full query, but if you just focus on the part in yellow, is source of. So what we did is we added the graph table syntax from SQL to PGL. And we also made sure that any kind of legacy PGL syntax that did not end up in the standard, or that did not standard become, the syntax does not look exactly the same in the standard. We basically made sure that whenever we see graph table in a query, but we see some legacy PGL syntax, that we give some error and kind of guide the user how to fix their query. So here we have is underscore source underscore of, which is some old PGL thing. And the SQL standard standardized SB is source of E. So you now get a nice error message saying how to fix your query so that it becomes more standard compatible, and therefore the query will become runnable both in Oracle Graph Server and in Oracle Database. There are two cool new features that we recently have added to PGL, which are from features from SQL, but these features also are part of GPL, so they're really part of the core between SQL and GPL. So there's the path modes acyclic, simple, trail, walk. So what you can do, for example, here we met the top five shortest path, starting from this vertex and then back to that same vertex A. And we only want simple path. So a simple path is a path that doesn't repeat any vertices, except for possibly the first and the last vertex in the path. So even though we ask for five paths, we only get two because only two simple paths exist. So here we have two edges, that's why we get two paths. And we do some aggregation and get so this is a financial graph, so there's the amounts, dollar amounts along the path, and that's what we aggregate together. So we have two paths with 4 edges each. And besides simple, there's these other cycle avoidance modes like acyclic and trail. On the next slide, we do the same query, but this time we add this 1 row per step. And what does it do? That kind of unnests the path. So we had 2 paths and with 4 edges each. And now therefore we get 8 rows, 4 for the first path and 4 for the next path. So this allows you to unnest vertices and edges along path, and that also allows you to do pattern matching after unnesting. That's not on this slide, but you can do a lot more complex queries this way. So to summarize, graphs can be created and queried in SQL. A converged database like Oracle Database combines the power of relational graph and JSON. Since graphs are part of the SQL engine, all existing tools and programmatic interfaces that exist for SQL also work with graphs. And then PGL will help with the transition to SQL by alignment to SQL. All right. Any questions about this? Thank you.
Thank you for your presentation, Oskar. I wondered if you could um, explain Oracle's position on GQL rather than the kind of SQL-ish explanation you gave in your presentation.
Right. So I believe, yeah, Oracle obviously wants to keep a good eye on GQL and see what happens, monitoring it, and of course keep collaborating and make sure that the common core stays the same and that we exchange ideas. But right now we don't have a plan to implement GQL, but we definitely pay attention to it. Alice, you were first.
Sort of related question. I believe in PGQL you have some DML statements. You can actually, modify the graph. And I guess what's been done with SQL PGQ sort of poses the question: how do you update the graph? And right now, my understanding would be you'd modify the underlying tables of the graph view in order to achieve that. What do you have in mind going forward? Would you see commonality between DML that might come into the picture with the DML in GQL? It's kind of relates to Jim's question, because the finger points towards quoting more GQL, and that sort of naturally from this model that you have.
Yeah, it's true. SQL PGQ does not have graph insert update delete, and kind of depends on the updates to happen on the underlying tables. But right now we are still kind of wait and see how this works, and I think many customers would be fine with this because they understand the mapping between table and graph, and they don't have problems with updating underlying structure via table or maybe JSON insert update delete. And it's kind of unclear whether we necessarily need to have specialized graph insert update delete in SQL PGQ or not. If so, how we will do that exactly.
Thanks, nice talk. Is there anything you can say about the implementation? So you said PGQ is sort of a staging language to get people to SQL, and then SQL will run on the main Oracle engine. How did you change the engine, or did you change the engine to add support for graphics?
I mean, there's different implementations. Because Oracle, for example, also has an in-memory option. There's some ideas to extend that to also have support in-memory graphs. But right now, what we support is basically translate underneath it gets translated into existing SQL operations. For example, recursive width.
So basically my question was very related. You have shown the multiple ways, multiple syntaxes for doing paths, paths being one of the biggest, big hit features that deserve, justifies going for graphs. So if you were to consider all the 4 flavors of path that you've shown there, so that is currently implemented with recursive SQL queries?
This we have in the Oracle Graph Server, it's implemented using specialized data structure and Java implementation.
Okay.
Whereas we also have the translation to SQL, and that one is using either recursive width or PL/SQL. And in some cases we use one, some cases the other. Yeah.
Please walk up.
Going over.
It's okay. You don't have the speaker for the session, so.
Thank you. I think you mentioned at the beginning there's a difference between schemaless and relational data in Oracle. Can you explain a little bit about that difference and implications to query?
So the schemaless is really based on existing JSON and XML functionality. So in Oracle database, and this is also part of SQL standard, you can have a JSON object in a row column intersection. So you can you can have a JSON column with a bunch of JSON objects. And this can be schema-less, but you can also add rules to make those JSON objects schema full, essentially. And these objects can be used just like they can be used inside tables. Since graphs are built on tables, therefore the JSON object can also be exposed in the graph. And you can do inside your query, you can, for example, drill down inside it into this one of these JSON objects to get your values out.
Thanks, Oskar. Nice talks. I have a question with respect to supports of JSON and graphs and relations and other data models. Are you going in the direction of polystores? If you have multiple data models, and you have a metadata model to query them?
I guess I'm not familiar with polystores, and I mean we definitely have. I mean it sounds like multi-models. That's what we're doing. I mean that's kind of the idea of this converged database. But you're asking then if we support this.
You know,
query on
the
top
fact
language.
that you have JSON. I
Yeah.
mean, what is the intuition of combining JSON with graphs and relations?
Mostly just because a lot of JSON and relational, there's just a lot of JSON and relational data out there, and a lot of users are using it and benefiting from all those all that data out there. If you can use that as a graph, then all this data can just be easily reused and to do more things.
Thanks.
All right, well, thanks, Oskar, again.